In 1947, a team of researchers took a group of volunteers and tied a stout string around their middle fingers and attached it to a spring balance that measured tension. The volunteers then slowly pulled while x-rays were taken of their middle finger joints until their knuckles cracked. The goal of this strange-seeming project was to figure out why knuckles pop or crack when they are pushed or pulled. This 1947 team was the first to investigate this, but definitely not the last. 70 years later, a paper was published that may finally answer this question. But there is a second major question about knuckle cracking that remains unanswered. Specifically, we don't know whether knuckle cracking is bad for your health. For example, we don't know whether it causes arthritis in the long term, but not because scientists haven't tried to find out. While we haven't reached our final destination in knuckle cracking research, the journey has been fascinating on its own. Allow me to explain. There is no other issue on this planet more divisive than knuckle cracking. Some people can't even stand the sound and refuse to attend any party that might have knuckles present. Others crack their knuckles several times a day, scoping out dark alleyways to walk down where they beg strangers to pull on their fingers for some of that sweet, sweet crack. Historians agree that the previous sentence is the first known arthrological pun about doing crack in an alleyway. But regardless of your feelings about knuckle cracking, every one of us is chock full of knuckles, so let's discuss them. First, let's talk about where the sound comes from. I've already mentioned the first study that discusses this, a 1947 study by Roston and Haynes. Using, quote, very strong tension up to the limit a subject can bear, they took many x-rays, where the number of exposures available from a single individual was limited by considerations of safety to about 15. You can tell that this study was from the 1940s, where regulations about participant safety were a little bit different, because they were more concerned about the dangers of X-ray exposure than they were about pulling on people's joints until they couldn't stand it anymore. From their X-rays, Roston and Haynes hypothesized that the noise was associated with a gas bubble. This gas bubble forms when liquid around your joints experience low pressure, such as when you pull your bones apart from one another. Because there is gas dissolved in the liquid, called synovial fluid, the gas moves to the low pressure area and pops into existence as a little bubble. It's like opening a can of carbonated soda and watching all of the little bubbles rise to the surface out of the liquid, but louder. But I looked at those x-rays from the study and I don't see any bubbles. Do you? Maybe I don't know what the bubble looks like, or it's just a bad scan, or maybe the bubbles popped in the 70 years since the photo was taken. One last fun fact about this study is that Roston and Haynes established a 20-minute refractory period for knuckle cracking. This means that until the gases disperse back into the liquid, you temporarily cannot crack the same joint again. Then, in a fascinating study from 1971, a team of researchers, Unsworth, Dowson, and Wright, came together to combine the highly technical method of pulling on people's fingers with a new study in which they built a giant knuckle model and then cracked it. Isn't science beautiful? In this study, which was phenomenally done for its time, people were strapped into a machine and oh my gosh, there's a picture. Of the 17 people that participated, only 5 people actually successfully had their fingers cracked. The researchers claimed that this was because some of the subjects did not sufficiently relax in order to allow the machine to do its job. Gee, I wonder why. Could it be because a strange contraption was trying to pull their fingers off? But anyway, they found more evidence of a bubble forming when the knuckle cracks. And their model of a knuckle? It totally worked, and it produced a cracking sound when they filled it with synovial fluid from actual joints. This paper went into more detail than the paper from the 40s did, and they even included math. See? I'm not going to pretend that I understand this equation, I'm just going to be impressed by it. But the researchers came to a different conclusion than did Roston and Haynes. Instead of saying that it was the formation of the gas bubble that caused the cracking noise, Unsworth, Dowson, and Wright tried to claim that it was the collapse of the gas bubble that caused the noise. So now we have 2 theories. Serious attempts to solve the mystery of the cracking noise were not made again until a pair of studies were published in 2015 and 2017. But we'll come back to those later. First, I'd like to spend some time discussing some of the more ridiculous knuckle cracking studies. Specifically, a few brave pioneers began to attempt the other question that we are discussing today. Does knuckle cracking harm your health? The first real attempt to answer this question was a correlational study from 1975 by authors Swezey and Swezey. One of the Swezeys was a doctor, and the other Swezey was his 12-year-old son. Authoring a medical journal paper at age 12? When I was 12, I was mostly writing Pikmin fanfiction. You're welcome, Internet. But anyway, Swezey the Younger had apparently gotten into an argument with his grandmother over the whole knuckle-cracking causing arthritis thing. And so the Swezeys set out to conduct a study. They went to an old folks' home and began to ask people whether they had cracked their knuckles when they were younger. They then asked the people to demonstrate a KC maneuver, which is fancy doctor speak for asking people to demonstrate that they could crack their knuckles. They found 6 people who had been knuckle crackers when they were younger and 22 people who had not. I reached out to Swezey the Younger for comment on this article, but he didn't get back to me. In the end, they were not able to show that knuckle cracking when young made a difference in old age. However, there are some pretty serious limitations to this study that we should discuss. First, the sample size is limited. Only 28 people total from a single old folk home is not enough to detect the health differences that we are looking for, especially if you want to control for differences in age, gender, and race. Moreover, this research depends on accurate, self-reported memories of knuckle-cracking behavior, which in an elderly population is not guaranteed to be accurate in all cases. Based on the trend reported in the paper, I did a quick power calculation and found that if they wanted to find the effect of knuckle cracking that they were looking for, they would have needed literally hundreds of people to participate in this study. But what doctors would have the time to conduct such a large-scale study? Enter Castellanos and Axelrod. In 1990, these two doctors published a correlational study with a sample size of 300 people over the age of 45. They asked each of these 300 people about their behaviors when they were younger, including whether or not they had cracked their knuckles as a habit. 74 had, and 226 hadn't, giving us a sample size more likely to allow us to detect an effect. And in the people who had cracked their knuckles when they were younger, 84% of them had noticeable hand swelling, more than the 6% of the non-crackers. Knuckle crackers also had weaker average grip strength. But the people who were knuckle crackers were also more likely to be smokers, drinkers, and have had manual labor jobs in which they worked with their hands than those who did not crack their knuckles. These confounds were not controlled for in the study, and so we don't know if these other variables contributed to the bad hand health. Additionally, we don't know how hand swelling was measured in this study, or if the experimenters were blind to which participants were knuckle crackers when they measured the hand swelling. Ideally, you would want the person doing the measuring of the hand swelling not to know whether the person was a knuckle cracker or not in order to remove all possible bias of the measurement. I attempted to reach out to Castellanos and Axelrod for comment on this study, but I was not able to reach them. If we really want to know whether knuckle cracking causes problems later in life, then we need to do a longitudinal study rather than a correlational study. In other words, instead of asking people who are already old whether they cracked their knuckles, we need to randomly assign a group of young people to either crack their knuckles or not, and then measure the effects of knuckle cracking as they grow up over several decades. If that sounds like a lot of work, you're absolutely right. But one guy was determined to try it. Donald Unger cracked only the knuckles on his left hand, but not the knuckles on his right hand, for over 50 years. He cracked his left-hand knuckles at least twice a day, amounting to over 36,500 cracks. He published a short letter in 1998 claiming normal function and no differences between each hand. This study had only one participant, or 2 if we're counting hands, so we can't really claim that our question is answered by it, and at least one statistician agrees with me. A statistician replied to Unger's letter with, quote, "The sample size appears too small to support accurate inferences. Typically, sample sizes of roughly twice the available research budget are required for valid inference. Restrictive eligibility criteria and convenience sampling limit generalization of the results to knuckle-cracking physicians with a lot of time on their hands." It was a marvelous undertaking anyway, and Unger won the 2009 Ig Nobel Prize in Medicine for his work. In 2010, Unger was interviewed by the Chicago Tribune about this research, and he remarked that to become famous for this stupidity seems very strange. No other papers that I'm aware of have made attempts to answer this question that come anywhere close to answering it definitively. And because it's impossible to prove the null hypothesis that there is no effect of knuckle cracking on long-term health, and because it would be extremely difficult and possibly unethical to randomly assign a group of kids to either crack or not their knuckles for several decades to see what happens, we may never have a definitive answer to this question. But while we don't have definitive evidence of long-term effects, we do have some good evidence that the short-term effects are dangerous. Namely, there are cases of people needing hospital intervention after attempting to crack their knuckles. Chan, Steinberg, and Bozenka report on 2 such cases in 1999. So it's probably safer not to do it at all. There are 2 more studies that we need to talk about. Published in 2015 by Kachuk and colleagues, and in 2017 by Boutin and colleagues, they circle back around to our original question of where the noise comes from. What makes these studies different from the original study published more than 70 years ago wasn't so much the method. They still just pulled on people's fingers and took pictures. But this time, they had advanced picture-taking machines. In 2015, they used an MRI to make a movie of a knuckle crack, and in 2017, they used an ultrasound to look at and listen to knuckles while they were being cracked. By the way, in the 2017 paper, they refer to knuckle cracking by a scientific term, which is distraction maneuver. So, if you wish to ascend to nerd nirvana, from now on you should refer to all knuckle cracking as distraction maneuvers. What they found was that Roston and Haynes were right back in 1947 when they claimed that the noise was associated with the formation of a gas bubble. But this time, both of the researcher teams were able to make movies of the gas bubble forming, showing the changes happening in the joint and revealing when the noises occurred. The 2017 research group also correlated knuckle cracking with grip strength, but they weren't able to find a reliable difference. In other words, while we have solved the riddle of the noise, we haven't solved the riddle of the health effects. But 50-50 on the riddles is pretty good. It's much better, for example, than my success rate when trying to contact knuckle cracking research authors.